Hello everybody and welcome to my tutorial where we're going to be talking about the file permissions in Linux-based systems. So what I have here a folder, and in this directory I have a couple of files in a folder. So I have one folder, one directory named test, and three files, test0, test1, and test2. And what I've done here is I've ran the command ls-l, which lists out the files in a detailed view like this. And what I'm going to do right now, I'm going to clear the console. So I'm going to clear the console and I'm going to do the command again. So the command is going to be ls-l. This gives us the detailed list view like this. Now, what we're going to be talking about specifically today is this first column right here. So this first column right here is the actual permissions for each file. Now, I'm going to specifically be explaining what all of these things here mean. Firstly, I'm going to explain what does the first character mean. So there are totally 10 characters right here. So 10 characters. The first one is explaining, or it's showing to us what is the file type. So what kind of file we're talking about, or what's the file type. So that's what the first character means. D means that this thing here is a directory. If it's just a dash like this, that means it's a regular standard file. It could be a text file. It's probably a text file if it's just like this. So it's going to be either a text file or something like that. That's going to be kind of like a regular type of file. The D is going to be a directory. Now there are obviously more types, and I'm just going to open a file here where I'm going to explain a little more about what kind of types there are. So the dash is a regular file. So that's what we have here. For example, these textual files are regular files, as you can see. Then we have, I didn't mean to do that. So then we have a directory. D is a directory. C would be a character special file. L would be a link, so a link to another file. B is a block special file. P would be a named pipe file, and S would be a socket file for inter-process communication inside the system. The C and the B, those could be some devices, that are connected to the system, and you would read from those files. From the block file, there's going to be a fixed size of the block, but from the character file, there's going to be only 8 bits. So a character is 8 bits, and that's how would you read into chunks of 8 bits. That's kind of the types of files. So these are the types of files in a Linux system. And the first letter here, or the first character right here, represents the type of the file. In this case, we have one directory and 3 regular files. Now, after the first character, so after the first identifier here, so that's the file identifier, we have 9 more characters. And now I want to really I want to explain very well what those 9 characters mean. So I want you to imagine them as 3 columns, and as separate 3 columns. So the first 3 characters, the second 3 characters, and the third 3 characters. Now, what do they mean? The first 3 characters represent the permissions that the user has to the current file. The second 3 characters represent the permissions that the group has, and a group in a Linux system is a group where multiple users could belong to one group. In this case, when you create the system, when you set up the system for the first time, usually the group could be the same as the username, but it doesn't have to be. You could create your own groups, and you can add multiple users to a group, and then you can add permissions to the group, and everybody in that group would have the same permissions. So the second 3 characters here are the permissions for the group that the user belongs in. And the last 3 characters are the permissions for all others, so for every other user on the system. So that's how I want you to imagine them, like 3 columns with 3 characters in each. So this is the first column here. That's for the user permissions. This is the second, or for the owner, also known as the owner of the file. Then the second column, that's another 3 permissions for the group. And the last 3 characters, that's going to be the permissions for all others on the system. Now, let's dive into what does the R, the W, and the X mean. So now let's take a look at each column separately. Let's take a look at this first column right here. So what does the R mean? R means read. And if there's an R, that means that the user has a read permission to this directory. Then there's the W. What does the W mean? The W means that the user has a write permission to this directory right here. What does the X mean? The X means that the user has an execute permission to this directory right here. So that's what the R, the W, and the X mean. So R is for read, W is for write, and X is for execute. Now, what in this case we're concluding that the user has read, write. So the user has read, write, and execute permissions for this directory. Now let's take a look at the group. As we can see, the group also has read, write, and execute permissions for this directory. And now when we come to the all others, we can see something a little bit different. As you can see here, every other user on this system has the right to read this directory, but as you can see, there's an empty dash right here where the W was supposed to be or is supposed to be, and that means that every other user on this system doesn't have a permission to actually write. Doesn't have a write permission for this directory, and every other user has an execute permission for this directory. Now, from this we conclude that the user has all permissions to read, write, and execute. The group has all of the permissions for this directory, but when we're talking about all others, they don't have the write permission. Now let's take a look at this test0 file right here. Let's take a look at it. Firstly, we can distinguish that this is an actual regular standard file, and we distinguish that by this dash right here. Now let's take a look at the user permissions. So the user permissions are R, W, and then we have a dash on the third place. So what does that mean? The user has a read permission, it has a write permission, but it doesn't have an execute permission. That's exactly what that means. Now we can also see the second column here of 3 permissions, or the permissions for the group. These are the permissions for the group. We can see that the group also has read and write permissions, but it doesn't have execute permissions. Also, every other user on the system, or all others, have only read permission for this file, so they can only read the file. They cannot write to the file. They can only read the file. So the read permission says that we can open and read the contents of a file. Also, if we have a read permission on a directory, that means that we can list out the directory. The write permission stands for, can we modify the file? So can we add something to the file? Can we do something, can we change modified contents? And the execute permission stands for are we able to actually execute a file? For example, let's say there's a binary file, and if it doesn't have an X permission, or an execute permission, we're not gonna be able to run it. So in order to run a binary file, you're gonna have to have the X permission to it. Now that's about the permissions, and that's what they mean. Now I'm gonna come here to this file right here, and as you can see, we have the file types here. Now, and I'm gonna have a link in the description with this file here, so you can have it for yourselves, and you can use it if you want. And now, where are we gonna go? Now we're gonna discuss about the representation. So we already discussed the representation. Now we wanna discuss a little more about what does. This is kind of gonna be like repeating the things that I've just said right now. So there's a couple of representations of the permissions, and one of those is going to be the octal representation. So in this case, the number 0 means that we have no permissions. The number 1 means that we have execute permission. And why is that like that? Well, if we take a look, that will be 0, 0, 1. Let's do, for example, 2. 2 would be 0, 1, 0. So we're looking at the binary Let's imagine this is one of those columns, for example. Let's say this is the column for the user. In this case, the user doesn't have any permission. So that means that the user has 0, 0, 0. Let's represent these dashes as 0, 0, 0. And when there's a letter, let's say that there's a 1 in binary. For example, this will be 0, 0, 0. This will be 0, 0, 1, which is actually 1 in binary. 0, 1, 0. That will be 2 in binary. Then we can go 0, 1, 1. That will be 3 in binary. And so on until 7. So as you can see here, you could use a number, an octal number. For example, the 0 would represent no permissions. 1 would represent only execute permissions. 2 would represent only write permissions, because that will put a 1 here. So this would be 0, 0, 0, 1, 0. 3 would mean execute plus write, and so on. Now this is the octal representation using these numbers like this. We will go in an example later where we're gonna use these commands and this set here, this set of rules right here. Now I want to talk about the symbolic representation, where it's a little more intuitive, and you can use either way. So you can use this way or this way, but this one is a little more intuitive right here. But you can really choose between both of the ways how you're gonna use it in the commands. Now the symbolic representation, there's an operator. A plus means that we're going to be adding a permission to a file or a directory. The minus sign means that we're going to be removing a permission from a file or a directory. And the equals means that we're setting the permission right now and we're overriding all previous set permissions earlier. And then these are the user denotations. So these are to whom are we actually changing the permissions. U would mean that we're changing the user permission. G would mean that we're changing the group permission. O would mean that we're changing the permission to all others. And A is for all, so for everybody, for everyone. And right here I have some example commands. For example, so in order to change permissions for a file in Linux, we use the chmod command. And that's a command that we usually use in order to change permissions to a file. And the command it works in a couple of ways. So it can use the octal representation, or it can use this symbolic representation right here. So we usually run the command, we set the permissions, and we choose the file name which we want to modify its permissions. So we want to choose the file name that we want to modify its permissions. And now we're going to do exactly that. So what I'm going to do right now, I'm going to open the terminal right here. And let's try to, first of all, let's try to set, let's first try to use the, let's try to use the symbolic, not the symbolic, let's try to use the octal representation, and let's try to set the permissions for the test 0, and let's try to set it so that everybody has all the permissions. So the read, the write, and the execute. So I'm going to do chmod, and I'm going to do 7. 7 would mean that, so the first 7 here is going to mean, so how this works, the first number that we're going to put here is going to be for the user. And if I put a 7, that's going to be in binary 1, 1, 1. So if I bring this back here, a 7 would be 1, 1, 1, or read, write, and execute. Now, maybe a little more intuitive would be if I had this written down here like this. If I had like a 0, 0, 0, 0, 0, 1. Maybe this is a little more intuitive like this. Let me just do them like that. I guess that's gonna be a lot better like that. So let's do this in just a second right here. So let me do that. Okay, so this is gonna be a little more intuitive right now to as what I mean right now. So let me just so this is gonna represent a 0. Now when we say a 7, we're representing a 7 in binary, and that actually means that for the read, for the write, and for the execute, we're gonna have all of the permissions. And now if I do 7 right here, that's gonna set the user permissions. If I do another 7, that's gonna affect this column right here, so the second column, or the column for the user group. And if I put another 7 here, that's gonna affect the third column, or the column for all others. And now all I have to do after this is specify the file name. Let's do the test0.txt, and I ran it. So now if I do ls-l, what's gonna happen? As you can see, the file test0 has the user, the group, and all others have all of the permissions. So read, write, and execute. So as you can see, the command does actually work, and that's how it works. That's how it works with the octal representation. Now let's go with the let's go with the test one, and let's give it just read permissions. So we can go back here and we can see if we want to do just read permissions, we have to do 4. And that will be in binary 1, 0, 0, or that means that this one's going to be 1, so the first character is going to be 1, or that's going to be the R, and these are going to be zeros. So in order to do that, we have to use the number 4. So let's try that. Let's do chmod, and let's do 444, and let's do it to the same file. Let's change the permissions to the same file. Now I'm going to run LSL again, and as you can see, now we don't have every permission to everybody, but we just have the read permissions right now. So the user group, and everybody else has only read permissions for this file right here. So that's gonna be the octal representation. Now let's go with the symbolic representation. So I'm gonna list out the files again, and we're gonna try these symbolic representations right here. So let's try this command. So let's try this. So let's set the read permissions to all others, for example, and now we can do that obviously by. So let's say that let's not do read because everybody has read. Let's do write permissions to all others for the test0 file. So we wanna set. So let's say we wanna set to everybody else. We wanna set only. Let's say only read and write permissions. Let's just see how we do. Let's just say that we want to set read and write permissions, or let's just set write permissions because everybody has read permissions. So let's just set write permissions to everybody else for the file. Let's do test1 this time, test1.txt. Now if I do ls-l, we're gonna see that the test1.txt has write permissions, and all other users have write permissions because that's what we specified here. So the O means all others equal to V. So we're saying that's going to be equal to write. You have the write permissions. Now let's try these others. So let's try to add, for example, this because this actually sets to everybody. For example, the equal sets the permission and overrides all of the earlier permissions. But let's say we don't want to override the previous permissions. Let's say that I just want to add execute to, let's say, to test1. Let's say that I want to add execute. So what we could do, we could use this command, for example, this scheme right here. So we could add 2D. So we could do change mod, and we're going to be doing 2D all others. So to all others, we're going to be adding execute on the test1.txt. So this means to all others on the system, plus means that we're adding execute permission on this file right here. And if I do ls-l, you can see that now we have execute here. Now let's say we change our mind and we wanna, revoke the permission for execute. So a way to do that, I'm just gonna clear the screen and do this again. A way to do that is by using chmod, and then we're gonna be using, let's say to all others, we want to just revoke the permission for execute. So that's going to be the minus sign, and that's going to be obviously the X right here. And what does that mean actually? So that means that we're revoking the permission. And let's actually do it. So let's revoke it to the test1.txt. And as you can see, as soon as I run this command, now if I try to list out the contents of the folder, you're gonna see that it doesn't have the X permission anymore. So that's how you would use these commands right here. So that's gonna be kind of the overview of the Linux permissions of the file system, and that's the both ways that you can use them. So the octal representation or the symbolic representation. So that's gonna be it for this video. Hope you learned something new, and see you until the next one.